Next, we'll begin adding the critical components of any DNA hierarchy, be it SD enabled or not. This includes sites, IP pools, and credentials. I've listed the files in the directory for this module. Rather than try to create one giant script to automate the entire SDA deployment and its prerequisites, I've broken the process into discrete, ordered steps. This way, you can build the architecture step by step using shorter and simpler scripts. Naming the files in sequence is a technique I recently adopted for a real-life customer project, and I found it to be very effective. Let's begin by opening the first file to deploy some sites. All of the files begin the same way, with the shebang, module documentation, and some import statements giving us access to the JSON library and the DNAC requester. Let's jump into the main function first. All of the scripts also reference the dcloud DNA Center instance. I've commented out the DevNet details used in the other modules of the course if you want to use that sandbox instead. You can also plug in your own values if you are accessing a private DNA Center deployment. If your DNA Center already has the site infrastructure created from earlier in the course, you don't need to run this script. Seeing as how I'm using a new sandbox for the SDA demo, I need to recreate them. This time, we won't add any floors for simplicity. Inside the for loop, we open each of the files, which remain unchanged from earlier in the course. I've displayed the two JSON payloads for reference, creating the Maryland area and then the secret lab building. Then, I extract the site and name from this data and print a log message indicating the action to be undertaken. Then, we issue a post request to the site endpoint with the JSON payloads loaded from disk. Earlier in the course, I had a local function to check the execution status, but my opinion has matured since the original publication. I decided to add this functionality to the DNAC requester class because its applicability extends beyond just the site management API. I'll quickly open up that class and jump down to the wait for exec status function. The function requires a status URL with a default wait time of 5 seconds. I'm using a loop that runs forever instead of bounding it with a fixed number of retries. This approach is less safe that I generally don't recommend, but I wanted to demonstrate it for technical variety. Inside the loop, we'll wait for 5 seconds, then query the status URL and convert the body to JSON. Here's an example of a typical response in JSON, and we can check the success field to see our result. If the stream begins with the word fail, let's print the error message, otherwise we'll return the response object. Any other status, such as pending or processing, will cause the loop to run again. I rarely care about this response object, so we won't retain the value. As confirmation, we'll issue a GET request to query the specific node just added and print out its ID. This is nothing new. Let's run the script and wait for our sites to be built. This output indicates the successful creation of the Maryland area and secret lab building within it. Next, let's open up the second script, which builds our IP address pools. I'm starting deeper in the file because everything above this is the same boilerplate from the first script, and I won't be showing it again. Using the JSON payload shown in the callout, we issue a post request to the global pool endpoint to create the specified IP pool. This pool is a super network that covers the entire global hierarchy, and our subpools will be subnets from within this supernet. Before continuing, we'll wait for the execution status to complete. Next, we need to retrieve our secret lab ID using a GET request and targeting that specific site. We then extract the ID from the response and store it in a local variable to simplify the creation of our subpools. I'm creating both a data and voice pool, which is common in most enterprise deployments, and each one has its own JSON file. Here are the contents of those files, and each one gets loaded in series thanks to our for loop. Each iteration will issue a post request to create the proper subpool within the secret lab building, then wait for completion. Let's run the script and wait for our IP pools to be added. Alright, the script completed without any errors, and I'm confident the pools exist. Let's wrap up this clip by checking the third script, which adds credentials. Because the DevNet sandboxes come with default credentials, we didn't need to use this step earlier in the course. This time, we'll add credentials for the CLI and SNMP v2 read and write operations. I use a pair of lists and a dictionary to accomplish this. We first iterate over the URLs list, counting from 0 to 2 inclusive as we do it. The enumerate function allows us to count the number of iterations using the I variable. You could also accomplish this using the zip function to iterate across both lists in parallel, but I wanted to demonstrate a less common technique for diversity. We load in all of the different credential types as shown in the callout, then issue a post request to create each one in sequence. It's worth mentioning that the switches come pre-configured with these credentials, so we don't need to manually add them initially. If for some reason it isn't, you can console into them through the dcloud GUI and manually add this basic configuration. Once the task is complete, we store the credential ID and add it to the activation dictionary. This dictionary serves as the payload for another request that activates the credentials for use in onboarding network devices. Here's an example of what that payload might look like after the loop has completed. Since we are associating these credentials with the global site, we'll need to grab the global site ID and store it in a local variable. Then, we'll activate the credentials in that site using the payload we constructed, then referencing the global site IG we just collected. Last, let's run that script to create and assign the credentials. You'll notice that I printed out the activation payload to the console so we can clearly see the structure of that dictionary. Everything looks good so far.